Hello, calculus class. Today is day 7. We're going to do more differential equations with applications. So here's my key. The idea of finding a particular solution means we have to do antiderivatives. I've given a derivative, dy over dx, or a rate of change, and I have to undo it to find the original problem. So what I need to do, I need to bring this over here and put the dx over here. And then I have to take its antiderivative or integral, and I get y equals 1/3 x cubed plus x plus c. And I have this initial condition of 1 comma 1 that I'm going to use in my problem. So when I plug 1 comma 1 here, I get 1 equals 1/3 times 1 cubed plus 1 plus c. I get 1 equals 4/3 plus c, and therefore I get c is equal to negative 1/3. I can rewrite this equation as y equals 1/3 x cubed plus x minus 1/3. That is the particular solution for the specific equation I'm looking. And you always could check. If you took this derivative, you would get that original problem. Let's take an example. Again, I'm going to move this over here. I might rewrite this one as dy equals x at negative 3 minus 2 dx. Now I'm going to take its antiderivative or integral. Get y equals, well, let's see, I had to add 1, so x to the negative 2. Reciprocal is negative 1/2 minus 2x plus c. Again, I have initial value of 1 comma 3. Then I'm going to plug 1 comma 3 in here. I get 3 equals negative 1/2, 1 and negative 2 minus 2 times 1 plus c. I get 3 equals negative 5 over 2 plus c, which means my c is equal to, add to the other side, I get 11 over 2. So I rewrite this, I get y equals negative 1/2 x to the negative 2 minus 2x plus 11 over 2. These are doing antiderivatives. As you can see, I started the next problem knowing that I had the initial condition of 0 comma 250. I took the antiderivative and I got s equals negative 5t squared plus 50t plus c. I plugged in 0, 250, where 0 is my favorite number to plug in for these type of problems. And I get c is equal to 250. And then I can rewrite this as s equals negative 5t squared plus 50t plus 250. Okay, this next one is not too bad, but we have an initial condition of 2 comma 25. I'm going to move this over to the other side, cross it out, take its antiderivative. I get b equal, let's see, it's got to be t to the 6, so it becomes 1/6 t to the 6, minus, got to be t squared, 1/2, it's 3t squared, plus 3t plus c. Now I plug in my initial value that I have here. 25 is the v, is 1/6 times 2 to the 6 minus 3 times 2 squared plus 3 times 2 plus c. If I do all this, I get 25 is equal to 14 over 3 plus c. And when I'm done, I get c is equal to, well, that's 75 over 3. I get 61 over 3. So I can rewrite this equation as v equals 1 over 6 t to the 6 minus 3t squared plus 3t plus 61 over 3. That is the antiderivative of that problem. Okay, for this problem I have shown a drawing of it, of the cliff and the stone being thrown up and coming back down. And because this is in feet per second, my acceleration is going to be negative 32 feet per second squared, which is gravity in these units. So my velocity is the antiderivative of acceleration, which is negative 32. So my velocity is equal to negative 32t plus c. Well, what do I know initially? I know initially when t equals 0, my velocity is 128. What's really nice about this is when I plug in 128 is equal to negative 32 times 0 plus c. My c is just 128. So my velocity equation is equal to negative 32t plus 128. I want to know when does the stone reach its max height and what is the maximum height. So here at the max, whenever at the max, your velocity is equal to 0, so I make this equal to 0. I solve for t, and I get at 4 seconds, it hits the maximum height. Well, what is that maximum height? So my height equation is just the antiderivative of my velocity, or negative 32t plus 128 dt. My height equation is negative 16t squared plus 128t plus c. But again, I know my initial condition that when t equals 0, my head is 320. So I could just go ahead and plug in 320. Oops. Erase that. 320 is equal to negative 16 times 0 squared plus 128 times 0 plus c. So c is just 320. So my height equation is negative 16t squared plus 128t plus 320. That is a height for any time, but I know t equals 4. So I'm going to go ahead and plug in t equals 4. Negative 16 times 4 squared plus 128 times 4 plus 320. And h of 4 is equal to 576 feet. And that is the max height. So in 4 seconds it hits a maximum height of 576 feet. So I want to know when it hits the ground. When does it hit the ground? That's when h equals 0. So I take my equation of my h. So it equals 0. I don't like all those big numbers. Divided by negative 16. 0 equals t squared minus 8t minus 20. And I say, well, I can factor this. I get 0 equals t minus 10, t plus 2, and I get, for my time, t equals 10 seconds. That's when it hits the ground, because t equals negative 2 is an impossible situation. You can't go back in time. So what is the velocity when it hits the ground? So I have to do v of 10. Negative 32 times 10 plus 128. So v of 10 is equal to negative 192 feet per second. That's humming. It's about 131 miles per hour. So that could not really happen unless it was in a vacuum. So we have this car traveling at 60 miles per hour, which is 88 feet per second, and there's a deer 150 feet away, and it slams on the brakes, and it stops in 4 seconds. Does the deer get hit or not? Well, because I say it's constant acceleration, which we're always going to use for all these problems, unless you tell you different. It's constant acceleration. It's linear, so my acceleration is change of v over change of t, so my acceleration is negative 22 feet per second squared. And so now I'm going to do my velocity is equal to the integral of a, which is the antiderivative negative 22 dt, v equals negative 22t plus c. But when t equals 0, my velocity is equal to 88. So I plug it in there, and I get 88 equals 0 plus c. So obviously c equals 88. And my velocity equation is negative 22t plus 88. That is my velocity equation. Let's figure out my distance. Well, distance is just the integral of v, which is the antiderivative of negative 22t plus 88 dt. So distance is equal to negative 11t squared plus 88t plus c. But when t equals 0, my distance is also equal to 0. I plug that all in there. C equals 0. Well, my distance equation is negative 11t squared plus 88t. Here's my velocity equation, here's my distance equation, and I want to know at 4 seconds, so I'm going to use t equals 4. And d of 4 seconds is equal to negative 11 times 4 squared plus 88 times 4. So my distance traveled turns out to be 176 feet. That's how long it will take for the car to stop after it hit the brakes. Well, since the deer is only 150 feet away, yes, it gets hit. I think maybe we have a situation here. Okay, next situation where we're going to drop a ball and it hits the ground with a velocity of negative 80 meters per second. I want to know the initial height. So, because it's in meters, my acceleration is going to be negative 10 meters per second squared, so my velocity is equal to the integral of a, which is the antiderivative of negative 10 dt. So v is equal to negative 10t plus c. But when t equals 0, my initial velocity is equal to 0 because it's being dropped. There's no initial velocity given to the ball. So I plug these in here. 10. 0 equals negative 10 times 0 plus c, so c equals 0. So my velocity equation is negative 10t. So my ending velocity is negative 80. So I plug that in here. And I get t equals 8 seconds. That's how long it dropped for. So let's do, what is the height? So my height is the antiderivative of my velocity, which is antiderivative of negative 10t. So my height is equal to negative 5t squared plus c. This is where things are going to come in important here. So I don't know the initial height, but when it hits the ground, I know h is equal to 0 and t is equal to 8. So I'm going to plug those in there. 0 is equal to negative 5 times 8 squared plus c. 0 equals 64 times 5 is negative 320 plus c. So c equals 320. And that is the initial height. (320 meters) is the initial height of the cliff or whatever we're dropping from. So for this problem, we have a block sliding down an inclined plane. It has some initial velocity and a constant acceleration, which means it's linear again. So I have to figure out what is the initial velocity given that it went down 75 feet at 3.75 seconds. Well, v equals antiderivative of a, given of 8 dt, b equals 8t plus c. Well, at t equals 0, I don't know its velocity, so I plug in 0. I get v sub 0 is equal to c. So my velocity equation is 8t plus v sub 0. Again, I don't know what that is. It doesn't matter. So my height on this block is the antiderivative of my velocity, which is 8t plus v sub 0 dt, and height equals 4t squared plus v sub 0 t plus c. Well, my initial distance at t equals 0, my distance is equal to 0, or my height, or whatever you want to call it. It's called distance. So that means my c is just going to be equal to 0. I think I've shown that enough. Let's grade it. So my d is equal to 4t squared plus v sub z t. What do I know? Well, when t equals 3.75 seconds, my distance is equal to 75. So I'm going to go ahead and plug that in. 75 equals 3.75 squared plus v sub 0 times 3.75. This is equal to 56.25, and when I subtract it over, I get 18.75 is equal to 3.75 v sub 0, and I get v sub 0, the initial velocity is 5 feet per second. Okay, the last example, I have this jet needs to take off at 100 meters per second. It says it can accelerate from 0 to 100 meters per second in 25 seconds. This acceleration has to be constant. So A equals 100 over 25 equals 4. So V equals antiderivative of A, or 4 dt. So V equals 4t plus c. But I know at the beginning, at time 0, my velocity is also 0. So again, I think I've shown many times that when I plug in 0 for t, that this constant is just whatever it is. So V equals 4t. So now I have to figure out its distance. Well, distance is going to be the antiderivative of v, which is the antiderivative of 4t dt. So my distance is equal to 2t squared plus c. But again, at t equals 0, my distance is equal to 0. So again, this is 0. So d equals 2t squared. That is my distance equation. It takes 25 seconds for this to take off. So I'm going to plug in t equals 25. So d of 25 is equal to 2 times 25 squared. So the distance for 25 seconds is equal to 1,250 meters. But then I want a safety factor of 2.5. So safety factor, I'm going to multiply this by 2.5. So the runway length is equal 3125 meters. That is the length of the runway. It's just a little bit short of 2 miles. which makes sense. I do not want a runway that does not have the safety factor built into it. I don't want a runway that's only 1,250 meters. I want to make sure that it has extra time to take off.